All right, good morning, students. I want to show you how you can get Dix readings on this particular experiment, LO3, refraction through glass prism, which is rectangular glass prism. I want to show you how you can get the readings without performing the experiment. Yes, it is possible. And then from the readings you have gotten, you can plot your graph accurately. Now let's look at this block prism that is given. And then we are given the values of all the incident angles. You can see we have when it is 20 degrees, when it is 30 degrees, 40, 50, 60, and 70. We have to find the value of UT in centimeter, Vx in centimeter. So when you go back to the diagram, you will find out that the distance from here to here is my UT. The distance from here to here is my UT. That is what the examiner says we should measure. And equally, the distance from here to here is my Vx. So before you get this circle, you must first of all perform the experiment, and then you choose a radius. You choose a radius of your choice. Okay? So let me choose a radius of my choice here. I decide to choose 1.6. Now, I'm going to place this here. Use this protractor and do what? Going to use this compass, to get this. Okay? Then after doing that, you use your what? Your meter rule and measure the distance from here to here. And you equally measure the distance from here to here. Then the next thing you will do is to go and record it. Index your table. But I'm going to be showing you how you can get Dix readings without performing the experiment. So I will show you one formula that I will apply to get my readings. So the formula I will apply here is 1. I will use this formula that my UT, I will use this formula that my UT is equal to sine I multiplied by 1.6, which is that my radius I choose, okay? Sine I multiplied by 1.6. So if this angle here first is 20 degrees, I can now get my UT. So I will say my UT is equal to what? Sine 20. Sine 20 degrees multiplied by 1.6. Sine 20 degrees multiplied by 1.6. And if you press sine 20 in your calculator, you will have 0.54. 0.54. Sorry, you have 0.3. You have 0.342. This is what you have, 0.342. When you press sine 20 on your calculator, multiply it with 1.6. Then everything will give us 0.54. That's what I will have, 0.54. So because I have 0.54 and I am manipulating, I can neglect this 4 because it's not up to 5 to approximate. But if it is up to approximate, you can approximate this. So what I will now come here and write is that my UT here is 0.5. I've gotten this one. This one is 0.5, okay? This is 0.5. So you see how I got it. You see how I got it? So it means that my UT is now equal to 0.5. So if my UT is 0.5, let's go and capture the next one, which is when the angle is, when it is 30 degrees. When this angle now is what? When it is 30. So I will use the same formula. I'm going to use the same formula that my UT, look at it, is equal to sine what? I multiplied by 1.6. So that my UT is now equal to sine 30 multiplied by what? 1.6. So when you look at this, you find out that sine 30 originally is 0.5 times 1.6. So everything is 0.8, okay? You will now come here and write 0. Point what? 80. Remember, an experimental value must be 2 decimal places. You write 0.8. Okay? So I want us to go to the next one. So if I want to get the next reading, which is when it is 40 degree, I will say that my UT now, my UT is now equal to what? Sine 40 times 1.6. And we know that from calculator, sine 40 degrees, we give you 0.642. 0.642. So multiply it with 1.6. Everything will give us what? Everything is going to give us 1 point something. Okay? Everything is going to give me 1.027. Okay? So I can take 1.0, or I can decide to say, I can decide to take 1.10. If I like, I can pick this. If I like, I can pick this. If I like, I can as well write 1.0 on my readings. So I prefer taking what? Come here and write 1 point what? 1.10. Okay? Let me write 1.10. Then I will go to the next thing. UT again, when the angle is 50. Say UT is equal to what? Sine 50 times 1.6. So I will have it to be sine 50 times what? 1.6. So that my UT becomes equal to sine 60. Sine 60 will give us sine 50, not 60, sorry. Sine 50 will give us 0.766. So this is 0.766 times 1.6 times 1.6. So which will now give us what? This will give me 1 UT now is equal to 1 point what? 2256. So I can pick that this is 1 point what? Can make here to be 1 point what? 1.20. Okay? If you watch what I'm doing, make sure that this is 0000. Okay? So if I now want to get my UT, when it is 60, I can say this is sine 60 here, multiply by 1.6. Sine 60 is 0.866. 0.866 times 1.6. Then my final answer here will give me what? 1.0. 1.38. So I can approximate it and make it to be 1.4. So here is 1.40. So when you solve the last one, which is for this, you have the answer here to be 1.50. This is what you have, because ut there is going to give me sine what? Sine 70 times 1.6, which will give me 1.50. Okay? So this is how we can get our ut. I've gotten the value of my ut. And then if I want to get the value of my Vx, which is this, my Vx will depend on this value. So I'm going to show you a particular shortcut for getting my Vx. So I will use this formula that my Vx is equal to, this is the formula we use, Vx is equal to my ut divided by 1.5. This 1.5 is the refractive index of the glass. You know that 1.5 is an approximated value of the refractive index of this glass prism. So this is what I will use to get my what? My Vx. So now, for me to get my Vx, I say the formula is what? The formula for Vx is equal to ut over what? Over 1.5. So when it is at angle 20, when it is at this angle now, 20 degree, ut is 0.5. So I could have 0.5 divided by 1.5, which will give me that the Vs there is now equal to what? Use your calculator and press it. Use your calculator and do what? And press it. If you press it, you get something like 0.3333. So it means that my Vx at that point is 0.3. So I will come here and write 0.30. So the same thing, Vx, when it is 0.8, when it is 0.8, my Vs is 0.8 divided by 1.5, which will give me 0.5, which will give me 0.5. So I will come here and write 0.5. Okay, and when it is 1.10, we have my Vs to be 1.10 divided by what? 1.5, which will give us what? 0.7. So I will have the x to be 0.7. So this is exactly what you will do. This is 0.7. You put 0. You put 0. Then when it is 1.2, Vx is equal to 1.2 divided by 1.5. So it will give me 0.8. So I will have 0.8 here. Then finally, this will give me 0.90, and this will give me 1.00. So you can see how I got these readings. Why not clap for me? Or you share this my video, you subscribe, comment, and like, because I will be releasing all the practicals here. I want you to score 40 over 40 this semester. And for those of you that want to attend my tutorial classes, I will also advise you to join us any moment from now. You can take my phone number on the screen. Then you join us. So this is how we can get these readings. Now let's go to the next question. The first question says that we should plot a graph of UT against VX. That is the first question. Plot a graph of UT against VX. So I want us to plot the graph now. Let us plot the graph of UT against VX, which is the first question. Okay, if I want to plot this graph, you will look at this. I've already done it. You look at this. You are plotting a graph of UT against VX. Now I've done that. Look at my graph here. This is my graph. I've done it already. Take a look at this graph. When you are looking at this graph, you find out that I started by choosing my scale. This is a graph. This is a graph of U2 against Vx. Follow it this way, and you score 40 over 40. So my scale is 2 centimeter represents 0.2 centimeter on UT axis. We don't say on X or Y axis here, but we normally use what we are plotting to represent the axis. So that is why I say 2cm represents 0.2 centimeter on UT axis, and also 2cm represents 0.2 centimeter on VS axis. You can practice this. So look at this. This point here is 0.0. You are not allowed to use pen to plot graph. I am using this pen so that it will be very clear for you to understand it. So, but then in the class, or sorry, in the lab, don't use pen. Always use pencil. So what you are plotting is that first thing says when it is 0.5, when UT is 0.5, my Vx is 0.3. So look at this. If here is 0.2, which means that this here is 0.1, 0.2, 0. What? 3, 4, 5, 6, just like that. So when it is 0.5, Vx is 0.3. So you take here is 0.5. If you check it, you see this one is 0.3. Then you connect these two lines. Connect these two lines, okay? You connect it. And always use dot. When you pick dot, you circle it. Don't use star. Don't use star. Don't use this to plot graph, please. This is what? Wrong. So after that, when it is 0.8, we have it to be 0.5. Check, this is 0.2468. This is 0.8. Then this is 0.4. Here is 0.5. So you trace it and you could get this, okay? So you can see the nature of my graph. See what I did. I want you to practice this graph. Follow it this way. And then you score 40 over 40. You thank me. Okay? Now, another thing that is important in this graph is for you to make sure that whenever you want to take your line of best fit, make sure it will pass through the origin. Because there is a question that says we should find the intercept. The intercept of this graph is expected to be 0. The intercept of this graph is expected to be 0, okay? So we move down to the next question there. The next question there, it says, plot a graph of UT versus Vx and record the slope and the intercept. So the first question says, question number 1, I want us to get the what? The slope. The slope is now equal to what? Change in UT, all in centimeter, put this unit, divided by what? Change in Vx, put this. So my slope is now equal to, if you check from this, you find out that this point here is what? 1.4. This is 1.4. Okay, let me put it this way. This is 1.4. This will give us what? 1.4. The slope is going to give me, let me position it in a way that you understand it. Yeah, this is 1.4 minus what? Minus 0.6. This, if you trace this like this, if you dot this line, you see it. This is 1.4. And this one is what? Check it. 0. What? 6. So divided by, let's go to the other one. If you trace this point is 0.9. So I will write 0.9 minus, if you trace this, you have it to be 0. This point here, watch it. If you trace this point, this is 0.38 because here is 0.3, 32, 34, 36, 38. So that is 0. What? 38. And then when you do this, you have that this will give me 0.8 divided by 0.52, which is now equal to what? 1.53. So that is a slope. And then this slope does not have a unit. This slope does not have a unit because this person and this can cancel out, okay? Now the next question says, that same question number 1, it says, record the intercepts. Record the what? The intercepts. So from this, you can tell them that the intercept, you can tell them answer, the intercept is equal to what? 0. The intercept is 0. The intercept is 0. That is what you write for them. Because you can say 8. I said you should try to make sure that this intercept will pass from 0. So that you can score your 40 over 40. Okay? Now the next question says, question number 2, says from your graph, deduce, says deduce what? It's asking us to deduce the refractive index. Refractive what? Index of the glass. Of the glass block. That is what the question says we should find. From your graph, deduce the refractive index. Okay? Says from your graph, deduce the refractive index. Refractive index. Refractive index of the glass block. So let's see how we can solve this. So from here, I can say answer from the equation ut, just write from this equation ut is equal to what? N multiplied by Vx. You will see this equation from your workbook or your manual. So this N represents the refractive index of the glass. So you can tell them that N is equal to the slope, which is the refractive index of the glass. So you say N is equal to slope of the graph. Therefore, the refractive index of the glass is the slope. is a slope. You can now say that n is equal to what? 1.5. That is exactly what I got from my graph. Okay? You can say it. This is 1.5, or I can say 1.5 what? 3. That is the refractive index here. Okay? So this is how I can comfortably solve this particular one. And then I will go to the next thing. I will allow you to understand it. Okay? Let me allow you to understand it. This is how you can solve it. This is how you can solve it. Yeah. This is how you can solve it. Because I want you to score 40 over 40 here. Okay? Now the next question says, state two laws of refraction. State two laws of refraction. That is the next question. It says, question number 3. Question number 3. State two laws of what? Refraction, not reflection. Be careful here. Now, my answer here is that just pay attention here. Pay attention. The first one is that the incident ray, we'll have that the incident ray, the what? The incident, this is the incident ray, refracted, not reflected. Be careful here. Refracted ray and the normal at the point of incidence all lie in the same, in what? In the same plane. This is the first law. This is what it states. So you can copy this. And be very, very careful. I think I have seen one that is on your work, on your textbook on page 99. That thing is a typographical error. So don't write it refracted ray because they will mark you down. Don't write it reflected because what I saw there was the incident ray, reflected ray, not reflected. It is the incident ray, refracted. This is refracted ray and the normal at the point of incidence all lie in the same plane. So if you write it, they will score you your mark, number 1. This is the first law of refraction. Now the second law of refraction states that the ratio of the sine of the angle of what? Incidence to the sine of the angle to the sine of the angle of refraction, sine of angle refraction is what? Is constant. Is constant for a given what? For a given pair of what? Media. This is exactly what you are going to write for them, okay? The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of media. So this is correct. So you can equally add for them that this is also known as this next law. You can say this is also known as what? Snake's law. So when you add this, they will give you your mark. So with this, you will score your 40 over 40, okay? With this, you score your 40 over what? Over 40. With this, you score your 40 over 40, okay? Now the last question says, state two precautions you took. Question number 3. Question number 3. Sorry, question number 4. Question number 4. State two what? Precautions you took. So the first one is that now when you are performing this experiment, you must ensure that the optical panes were erased. You understand? Tell them that you ensure that the optical panes were what? Erased. So I can say I ensured the optical panes. Or you can say the panes were erased. Okay? I ensured the panes were erased. Another one is that I ensured the pins were placed 3 centimeters apart. Another one, you can say I ensured the pins were spaced out. Okay? So all these things are the precautions that you can take anyone you feel like. So when you take these precautions, anyone is correct. So if you now want to join the White Faraday, this is my phone number here, 07036 221432. You pick this as my phone number and chat me. Always try to, share my updates. I want to, at the same time, to like, comment, and share this. Subscribe to this, my YouTube channel, and follow me, my subsequent videos, because I'm going to be releasing all the practical videos here. Thank you, and God bless you. I love you guys. Bye-bye.